Hi everyone, Noah from Business School Broadcasting here, and today we're going to be looking at some applications of time value of money and how we can actually put them into practice with some hypothetical real-life scenarios. So $100 today and $100 1 year from now are not the same, but why? A straightforward and simple answer to this is that money can earn interest. A 10% interest rate, for example, will provide me with $110 altogether by the end of next year. To put it simply, this is a famous quote. A dollar today is worth more than a dollar tomorrow because money has interest earning capacity. This can be demonstrated using a timeline. Let's take a look at a visual representation of time value of money using a timeline. A timeline consists of a horizontal line with equal time intervals representing periods. This could be months, days, or years, and the cash flow. When money moves around from one period to another, it involves interest. And when we're dealing with financial mathematics, a timeline is commonly used, and drawing a timeline can help to clearly identify the timing of when the money is received or paid out. Now let's introduce three main rules when we're looking at time value of money. Given that money has different values dependent on the time it is earned or paid, three rules need to be taken into account. Rule number one is that combined and compared money only at the same time period. So to represent that with a timeline where we have, let's say, $5 cash flows occurring at each period. We can't then go and add these cash flows together because they have occurred at different points in time and over different periods. So the second rule we're going to look at when we're dealing with time value of money is that moving money forward in time to establish a value is called compounding. Let's represent this with a timeline. So we have our timeline. Now, all we've done here is we've moved our money from period 0 to period 2 to establish an end value. And that's the main idea with this rule of compounding. Our third rule when we're dealing with time value of money is that moving money back in time to establish value is called discounting. Again, we'll look at this with our timeline. So again, what we've done here is we've just moved our money backwards from the future to establish a value at time 0. And that's the concept of discounting. Next, we're going to introduce some important terminology. So, future value is the value of an asset at a future date based on an assumed interest rate. The future value is important to investors and financial planners as it uses it to estimate how much an investment made today will be worth in the future. In other words, the future value uses the given interest rate and the cash flows to calculate the value of an investment after a number of periods. This is our future value formula. So, FV is equal to the future value, PV is equal to the present value, which is the value today, which we invest at t equals 0. I is the interest rate, and N is the number of periods. So to calculate this, we multiply the present value by 1 plus I to the power of N, and we'll use this formula later on in our example. So, for example 1, let's say you're looking to buy a car in 5 years from now. You invest $7,000 today in a savings account at 2.5% interest per annum. How much would you have in 5 years' time? So to solve this question, let's first work with what we know. We know that the present value is 7,000 because that's what we're investing today. We know that the interest rate is 2.5% per annum. We know that N is 5 because we're investing for 5 years, but we don't know the future value. So first of all, let's represent this on a timeline where we have 0, 1, so all we've done here, we've just populated our timeline with our present value, our interest rate, the number of periods, and here we're going to work out what the future value is. So recall the formula from the previous slide. We can now use it to solve for our future value. So we have FV equals PV multiplied by 1 plus I to the power of N. So remember that our PV was $7,000 and our interest rate was 2.5% and our N was 5. With this formula as well, we have to express our interest rate as a decimal. So 2.5% becomes 0.025. Then we can continue on. Multiplying this out gives our future value as $7,919.86. So we can also say that the answer to this question, when we interpret that answer, is that if we invest $7,000 today, in 5 years' time, we will have $7,919.86 to spend on a car. We can also solve this question using our financial calculators. So first, we'll start by clearing the memory, pressing Shift down and C. And next, we'll enter 7,000, followed by the PV key, which is present value. We enter it as a negative as well because the money going out of our pocket into the account. Then we enter 2.5, followed by IYR, which is also our annual interest rate. And then lastly, we enter 5, followed by the N key at the top, which is the number of periods. Then we just hit FV, and that returns the same future value as we calculated in the previous slide by hand. Now let's have a look at present value. Present value is the current value of a future sum of money or stream of cash flows given a specified rate of return. Future cash flows are discounted at the discount rate or interest rate. We're going to use those terms interchangeably. And the higher the discount rate, the lower the present value of the future cash flows. So in other words, the present value can tell us how much we would need to invest today in order to save a certain amount given an interest rate and time period. So the formula for present value can be derived with a very simple algebraic manipulation. And all we do is divide PV by 1 plus I to the power of N and swap the sides. Therefore, the formula for PV becomes FV divided by 1 plus I to the power of N, where FV is still equal to our future value, PV is equal to our present value, I is the interest rate, also known as the discount rate from this point onwards, because we are discounting the cash flows now, and N is the number of time periods. So let's have a look at our car example from earlier on, but from a present value perspective. So you're looking to buy a car for $10,000 in 5 years from now, holding the price constant. The bank has offered you a savings account paying 2.5% interest per annum. How much will you have to deposit today to meet your savings goal? So let's work with what we know again. We know that the future value is $10,000. We know that the interest rate is 2.5% per annum. We know that N is 5 because we're still investing for 5 years. But we don't know present value this time. So Again, we're going to populate our timeline. So we don't know our present value at this point. We know our future value equals $10,000. We have our time periods, which go 0 to 5. And we know our interest rate, which is 2.5% per annum. So let's write out our formula again. So PV equals FV divided by 1 plus I to the power of n. So substituting the values in, we have 10,000 over 1 plus, and remember we express our percentage as a decimal again, to the power of 5. Therefore, our present value is equal to $8,838.54. So to interpret our answer in the context of the question, what this means is that to have $10,000 5 years from now at our given interest rate, we have to invest $8,838.54 today. So again, we can solve for present value on the financial calculator with the following steps. So first off, we're going to clear the memory again with that shift down and C. And next, we're going to enter 10,000 followed by future value, or FV. Then we're going to enter 2.5 again, which is still our discount rate now, followed by the IYR key. Then we hit 5, followed by N, which is our number of years we're investing for, and then PV. So that returns that same value as we calculated on the previous slide of $8,838.54. So here's 2 questions for you to start thinking about in preparation for the next level of time value of money. So the examples we've looked at today involve only one cash flow. So what if we had multiple cash flows over the time period? Or what if interest is compounded more than once a year? For example, monthly or quarterly or daily or continuously. So these questions will be discussed in your classes. So I hope this video has helped you establish a good understanding of what we've learned today, as cash flows are an important part of future finance studies. Thank you for watching. I'm Noah Bloomberg from Business School Broadcasting, and I'll see you in the next one.